All right, so I said in the last video I was going to do another example where the importance of separating out our factors in the denominator correctly is going to be paramount. And so here's a case where that comes up. So our denominator here is x cubed minus x squared minus x plus 1. And if we use factoring by grouping, I can say, well, this is this, x squared times x minus 1 times x squared x minus 1, which is the same as x squared minus 1 times x minus 1. If you don't remember that one, you might want to check out an Algebra 2 textbook. It's a useful one. Okay, so I can factor this into x squared minus 1, this denominator here, into x squared minus 1 times x minus 1. So you might think, oh, well, I can make this, well, or I'm not going to write it like that. I can take this guy, 4x squared over x cubed minus x squared minus x plus 1, and separate it into something over x minus 1 plus something else over x squared minus 1. And since this is linear, then I'm going to have a constant, a zeroth factor expression in the numerator. And since this denominator is quadratic, I should have a linear factor in the numerator. Okay, so I got a over x minus 1 plus bx plus c over x squared minus 1. I'm going to run into trouble here, though, because obviously I have not completely factored this side, this denominator here. So when I factor that, I've got x squared minus 1, that's equal to x minus 1 times x plus 1. So what essentially I've got, you see I've got an x minus 1 in here, hidden in this side, and x minus 1 over here. I have repeated factors, but I haven't put them together. If I try to use partial fractions on this, a over x minus 1 plus bx plus c over x squared minus 1, ain't going to work out. I'm going to end up with some bad stuff. I don't even want to talk about it, right? So what I really want to do is say, well, what I've got is 4x squared over, I've got 2x minus 1, right? I've got x minus 1 squared times x plus 1. So that means I've got something over x minus 1, something over x minus 1 squared. Remember how we deal with these linear factors. I'm just dealing with the x minus 1s right now. Repeated linear factors. We'll have the factor once, and then the factor twice, up to however many times the factor appears in the denominator. And then over here, I'm going to have something over x plus 1. Now, each of these will be 0th degree expressions because all of our numerators are linear. Remember, it doesn't matter that this is repeated here. X minus 1 squared, x minus 1 is repeated here. It's still x minus 1 is the factor. That is linear, so the numerator is a constant. And then I would go through and do my usual steps. I guess since I'm just making this one video, I'll do that. Think about, what do I have to multiply this fraction by? Well, I want to have, in order to combine these three fractions, I'm going to have each one have the denominator x minus 1 squared times x plus 1. Well, what is this one missing in the denominator? It's missing an x minus 1 and an x plus 1. So I will have a times x minus 1 times x plus 1. What is this fraction missing? It's missing x plus 1, right? Because it's got the two x minus 1s. It's just missing the x plus 1, so that's going to be b times x plus 1. And then c, this fraction, the last fraction here, is missing both x minus 1. So it's going to be c times x minus 1 squared. And when I multiply that all up, add it up, it's going to come out to 4x squared, which seems like kind of a letdown. It's all right. Now remember, x minus 1 times x plus 1 is just x squared. That's just x squared minus 1. So what I end up with here is ax squared minus a plus bx plus 1 plus, and then what is this? This is x squared minus 2x plus 1. So I end up with cx squared minus 2cx plus c, and all of that equals 4x squared. Now, this is going to look a little silly, but there's a lot of terms in here, and you want to keep track of all of them. You might think, oh, well, I've got two x squared terms, and just all I've got on the right-hand side is an x squared term. So I don't have to care. All I care about is these x squared terms on the left-hand side. Not the case. Start with, these in different colors. Start with our x squareds. Ax squared plus cx squared equals 4x squared. Okay? So a plus c equals 4. What do we got else? Now we got our x terms. These are important, just as important as the x squared terms. We've got bx and negative 2cx, and that equals, obviously there's no x term over here, so that equals 0. So b minus 2c equals 0. And then finally we have our constants. I made a mistake here, didn't I? Yeah, this should be bx plus b, right? Bx plus b. Yeah. I've got negative a, b, and c, and they add up to, those are my constants, negative a plus b plus c, and they add up to 0 because there's no constant term on the right-hand side. All right, so it's cool. It's not that pretty, but it's, you know, it's doable, right? We got 3 equations, 3 unknowns, so in principle we should be able to figure this out. So I got some color to unify all these. C equals 4 minus a. So b minus 4 times 4 minus a equals 0. So b minus 8 plus 2a equals 0. And what do I want to do with that? I'll say 2a plus b equals 8. There's probably a better way to do this, but that's how I'm going to do it. I'll say negative a plus b plus 4 minus a equals 0. So I've got negative 2a plus b equals negative 4. Oh, that does work out kind of nice. So now I can bring this guy over here. 2a plus b equals 8. Add those together. 2b equals 4. So b equals 2. Then if b is 2, what is a going to be? 3. Yeah, 6 plus 2 is 8. And then c will be 4 minus a, so c will be 1. Oh, God, those are so pretty. So pretty. Okay, you do want to take this one to prom. Because what do we end up with? Well, we started out with 4x squared, x cubed, minus x squared, minus x plus 1 dx. Ugly. Ugly. Right? Not nice. Not something you want to see. Right? Oh, but look at this. What do we got now? We've got a is 3. 3 over, what was our first one? X minus 1. 3 over x minus 1 plus 2 over x minus 1 squared. Remember, that was our second denominator. Plus 1 over x plus 1 dx. And these are easy. These are easy as pie, right? Anybody can integrate these, right? My 7-year-old daughter can integrate these. Maybe not. Okay, but you see what I'm saying. We went from something really ugly to something relatively nice looking. Something that we can deal with without too much trouble. All right. So again, the lesson from this example is that you want to make sure that you're getting your factors when you factor it completely. See, the problem we had here in our first pass at it was that we did not factor this second denominator completely. Once you factor it completely, either you see how you have to separate it all out, or you see that, oh wait, maybe I have in this case we saw, oh, we have this x minus 1 appearing twice, so we have to put it in there 2 times. X minus 1 squared. Okay, so that's it, partial fractions.